Okay. Let me share screen. Switch it to Alex. Do you see Alex? Do you see Alex?
Yes.
Okay, good.
Yes.
Our subject is MAC1140 pre-calculus. I open this. Entonces, the thing I want to illustrate is the assignment I create for you. It's the only thing you should do. My assignment. No pie, no nothing. You click here, assignments. Open the assignments. And I create this assignment, que es 3 homework. Homework 1, 2, and 3, and 1 test. So far. Que es due the same day, February 1st. At midnight. Okay? This que es initial knowledge check, you don't care. I cannot delete. I don't know why I cannot delete, but you skip that. Okay, I create this home. This I create my homework 1, 2, and 3 and test. This is no. This is Alex, but this is I interpreted like a tours. When you open Alex the first time, make a tours and you navigate for the Alex, but you skip. I don't care if you get 0. 0 is not important for me. The important for me is homework 1, 2, and 3. But the homework is not mandatory. The homework is extra point. So you finish the 3 homework and the score in each homework is greater than 80%, you have 10 extra points. I highly recommend do the homework because it's 10 extra points and also it's very similar to the test. So the same problem that we are doing the homework with a different number, of course, same objective, you can see in the test. Okay? Okay? Entonces, I want que today you go to the www.alex.com and you sign in, no money for now because we're using financial aid code. Okay? Financial aid code. Here I want to see in your roster, everyone need to sign in before next Tuesday. Okay? Because next Tuesday we have class. Clear? Clear?
Yes.
Yes.
Okay. I don't finish. I have more detail. Entonces, es clear, Alex. O sea, en total, how many tests we have in total? In total, we have 10 tests. 10 tests, no. 8 tests. 8 tests. 4 chapters, for each chapter, 1 on paper and 1 online in Alex. And the final test is no mandatory. No. The final test, you see the whiteboard or no? No?
Which whiteboard?
No.
The Alex?
No, we see Alex.
Yeah,
Okay.
we see Alex.
No, I switching. I switching today. I switch.
No, sir, we don't see that.
Wait, relax. Relax. Switching to whiteboard. Now you see whiteboard?
Yes.
This
Yes,
final
sir.
test.
Yep.
This final test. Look, this final test. No mandatory. No mandatory. It's only for a student que, for example, fail one test or no fail. You need to improve your grade. So how you compute the final grade? When we have 8 tests, no? Test 1 on paper. Plus test 1 online. And so on. Test 2 on paper, test 2 online, blah, blah, blah. Divided by 8 is the average. Divided by 8 is the final overall grade. Suppose that you need to improve, not necessarily fail. You get B. The computation of this is 85. 85 is B, no? But I want to get A in the class, you take the final. Suppose that you fail the final, you are doing the mess, stay the same. The final help you to improve always. 0 in the final, 85. Improve, poster. Okay? Any question about the test? It's clear or confusing? And Alex.
Clear.
It's clear, sir.
Alex, you have to buy, guy. I don't know exactly why, but where in the bookstore is available. The Honte Campus. As for Alex, and the student can have no financial aid, you need to buy using your own money, no? Online. Okay, by the way, it's cheaper. I suppose that. When I finish every lecture, for example, today, I am recording the lecture. No, this part is not recording. When I start mathematics, it's recorded. When I'm recording, I send to YouTube. I have my YouTube channel. I send the video in the YouTube. You receive 1 second email que contain the link connected with the YouTube. So suppose that you have some problem and you cannot attendance in this lecture. You can see in YouTube or you rewatching in YouTube. Okay, you want to make sure something. And by the way, the student get subscribe in my YouTube channel have 5 extra points. Okay, the homework 10 extra points. Subscribe YouTube channel 5 extra points. One more thing you need to know. Test. YouTube. Yeah. Okay. What is the idea? The idea is you start working in the homework. This is my strategy, my intention. Well, so you are a student, you don't understand something, you're stuck in one question. So there are 2 possibilities. Possibility number 1 is I am working as a tutor Friday in the virtual room of the Honte Campus STEM lab. It's lab 1 p.m. to 5 p.m. Only that. You get in. So you don't know, I explain now how. And you are VIP person, no problem. I transfer to my room. I explain everything, no? It's a one possibility. Another possibility is anytime, but online, you email me. So by email, what information I need by email? I need the specific problem that you need, can I explain to you? But this is complicated because you cannot say, Professor, do for me number 5 problem. No. Because number 5 problem in your lab is different number 5 problem in my lab. When I open Alex, I see different. Okay, then you make a screenshot and send me by email the screenshot. First of all, you save the problem because some people send me a screenshot. Yeah, I solving. And to say now when I send, this is the answer doesn't match, Professor. The problem is that when you reopen Alex changed the number. Okay, so you save that problem, not submit, save, and make a screenshot, send me by email, I solve for you, I send the answer by email, and that's it. Okay? Do you understand the idea?
Yes, sir.
Dale.
Profesor,
Estoy en clase ahora. Después te llamo.
Perfecto.
Dale. Well, entonces, okay. Everyone know how you get inside the lab online in Honte Campus or no? Everyone know? Everyone visit the, no? Answer me, pero no by the chat, because when I in the whiteboard, I don't see the chat. You activate the microphone. Yes, no. No,
sir.
No, sir. Okay. Let me try. You open the Miami-Dade College homepage. Let me try to share with you. Boom. Do you see that?
Yes, sir. Yes, sir.
Yeah.
You go to academic, and select library. Scroll down, and you see online tutoring. Do you see? Online tutoring?
Yes, sir. Yes, sir.
Open that. You select the campus you want. Of course, I'm working in the Haunted campus. You open Haunted campus. And you select math and science. I don't want to click here because automatically open that. When you open that, you find a moderator. A moderator say, what help you need? No, wait. I am working with the Professor Taboada. Immediately, he or she transferred to my room. I can assist. This is from 1 p.m. to 5 p.m. only Friday. The rest of the time by email. Clear or confusing?
Perfect. So we don't need make an appointment for Friday.
No. You are my student. No appointment.
Perfect. Thank you.
Another tutor maybe. But with me no. Clear? Clear or not clear? Okay.
Clear, sir.
Okay. Do you see the whiteboard?
No, we see
No,
the.
we don't see the website.
Okay.
I mean that account.
Okay, switching to whiteboard. Do you see whiteboard now?
Yes.
Okay. My question is, everything is clear in the syllabus? Maybe you have another question. Entonces, don't hesitate asking any question. And please, this is online, but the attendance is mandatory. This is NDC live. And any problem you have, personal problem, you are sick or something, you communicate with me. Okay, the deadline is clear when it's due the test. Si you don't send me the test, I put F. Bueno, si you communicate with me, entonces I negotiate one new deadline, okay, or due date, okay, pero es important communication, online communication. The online class, you need to take, you need to have good computer, good internet connection. Si you have not this, taking in the campus, go to the campus, take another professor. With me, you have good computer and good internet connection. Are you ready to start mathematics or not yet?
Yes.
Okay.
I have one question.
Please go ahead.
So on the syllabus, if there's a test, that means there's one on paper and
Say
one
again?
online, Alex.
Okay. For each chapter, we have two tests. One on paper and one online. Online is Alex. And on paper is by email. This is your question?
Okay. Thank you.
Okay,
Yes.
super. Yes. Okay, so now, please, everyone now putting off the microphone, no noise. We start mathematics, okay? Okay, so now, the first topic we study today is about polynomial functions. Introduction to the polynomial function. Polynomial function. Polynomial functions. Okay. Polynomial, what is that? Polynomial is a collection of the monomial. And the monomial look like that. Look, f of x is equal. Suppose one hypothetical example, 2 x to the third power plus 4 x to the second power plus 5 x to the 1 power, when the 1 is omit, plus 10 is a polynomial, right? And this is a collection monomial. This is a monomial, this is another monomial, this is another monomial, and this is monomial, another monomial. The number in front is a coefficient. Look, coefficient, and coefficient. And the exponent is the degree. Look, this exponent is degree, degree 1 and degree 0, because this look like es no x is missing, pero you suppose que es x to the 0, and this is default 1. O sea, the exponent in yellow color is the degree. The degree of this monomial is 3, the degree of this monomial is 2, the degree of this monomial is 1, and the degree of this monomial is 0. And the coefficients of this monomial is 2, the coefficients of this monomial is 4, 5, and 10. And the degree of the total polynomial is the higher degree, que 3. That this polynomial, the degree is 3. Make sense? Make sense?
Yes.
That's definition. Okay, now, so you understand very well this. Let's start for the end behavior. End behavior, for example, let's using example to understand more clear. Example 1. Suppose this polynomial, f of x is equal minus 4x to the 5th power plus 6x to the 4th power plus 2x. Not always happen you have the collection 3, 2, 1, 0, no? Sometimes some guy is missing inside the polynomial. In this case, missing 3, 2, and 0. Now, the end behavior represent the dominant part. So the part increasing faster. It's obvious que when you plug it in here, a big number, so suppose end behavior is when the x approaches to infinity positive, or when the x approaches to infinity negative. So end behavior is when you evaluate the polynomial and the huge number, maybe positive or maybe negative. Okay, entonces the dominant expression, is the expression que contains the higher exponent, in this case to the 5th power. But the expression of the end behavior expression is obvious que es negative 4x to the 5th power, que represent the end behavior, the dominant. And what is important this? It's important because you know the end behavior, you have some idea how look like the graph of the polynomial. Look, we have 4 possibilities. We have this possibility. When the degree is even, degree of the end behavior is even, and the coefficient is a positive number, the graph look like that. Actually, I don't care what happened in the middle. So in other words, this is right up, look, right up, left up. Okay, that means when the x approaches to positive infinity, y approaches to positive infinity. In that direction, look. X approaches to positive infinity, this is x, and y approaches to positive infinity. This is this. And this is when the x approaches to negative infinity, y approaches to positive infinity. Okay, this is one possibility. Right up, left off, up. Another possibility is degree even, also. But coefficient negative. And negative value. Entonces es obvio que es similar, but it's going down, like that. Okay, it's right down and left down. In other words, when the x approaches to positive infinity, y approaches to negative infinity, is that part. And that part is when the x approaches to negative infinity, y approaches to negative infinity also. Is that part. Ok, entonces, when the degree is even, is up, up, or down, down. When the degree is odd, for example, degree 3, degree 5, degree 7, degree represent odd number, and coefficient is a positive number, the graph look like that. I don't care exactly what happened in the middle. It's not important. The important for me is the end behavior. Okay, entonces es right, up. Look, right, up, and left, down. Left is in that direction, down. It's equivalent to say when the x approaches to positive infinity, y approaches to positive infinity. This is that part. That part is this. And when the x approaches to negative infinity, y approaches to negative infinity. This is down. Okay, this is the graph of the one polynomial que have degree odd and coefficients positive look like that. Exactly, I don't know what happened in the middle here. And degree odd again, coefficient negative number is completely opposite. It's like that. Completely opposite. I don't know exactly. I put it this because I don't know exactly what happened in the middle. The important for me now is the end behavior. The end behavior is right down and left up. Okay, this is equivalent to say, when the x approaches to positive infinity, right, y approaches to negative infinity, down. And this is when the x approaches to negative infinity, left, y approaches to positive infinity, up. Okay, entonces this gives me some idea how it look like. Okay, a typical example, for example, suppose the graph of the even coefficient is positive. Suppose this example. 3 x to the 4th power. Degree even, f4. Coefficient is positive, is 3. The graph look like that. Like a parabola, but actually it's no parabola. Another example, degree even, coefficient is negative. Suppose negative 8 x to the 6th power. Degree even, 6, and coefficient is negative. Our graph look like that. Another example, suppose 5 x to the 7th power. Degree odd, que es 7. Coefficient is positive, que 5, positive 5. Our graph look like that. Like that. And one example is this, negative 4 x to the 5th power. Degree is odd, is 5, and coefficient is negative. It's down. Look like that. Okay. Now let's see example. End behavior, end behavior, end behavior. End behavior, end behavior, end behavior. Do you get the idea? It's clear or it's confusing? Opinion, guys. Clear, confusing. Clear, confusing.
It's clear.
It's clear. Okay. Super. Okay. So let's see example.
I'm sorry, sir. Are you recording?
Say again?
Are you recording?
No, I forgot. I need help. No, yeah, it's recording, yes. It's recording, yes. It's recording already, yeah. Okay, so may I erase the board? I bring a couple of examples. I bring a couple of examples. Look, in behavior and how look like the graph.
I'm sorry,
Example.
Professor.
Go ahead.
Are you gonna post this recording on the YouTube channel?
Yes. No. I recording in my computer. After or log to the YouTube.
Yeah.
Channel. Yeah.
Perfect.
Entonces now you will receive a new email with the link connected with the YouTube.
Perfect. Thank you,
Okay.
sir.
No problem. Okay, guys. Entonces now what's the idea in this couple of example? You determine the behavior and how you predict a little bit how look like the graph of the polynomial. Suppose this example. F of x is equal example 1 of the n behavior negative a x to the 5th power plus 6 x to the 4th power plus 2x plus 10. Entonces, what is the question? The question is, what is the expression que represent dominante? Okay, en behavior. En behavior. Es obvio que es the expression que contain the higher degree, this one. And the rest is ignored in the end behavior. It's minus a x to the 5th power. Now, you know, degree is odd number, fi, degree fi. And coefficiency is negative. Negative. And therefore, my graph look like, I suppose, like that. Yes or no? Okay, that's mean que when the x approaches to infinity, okay, to the right, y approaches to the negative infinity because it's going down. That part is this. And when the x approaches to negative infinity, y approaches to positive infinity. That part is this part. Any question? No?
No.
Okay, I want to complicate a little bit. Look. Example 2. Example 2 is the function g is equal 1 over 4 x 2x minus 3 cubic x plus 4 squared. This is different because somebody, not me, do the factorization of this. Entonces it's a little bit hard, or you expand a little bit, or no, you apply another idea. In behavior, look, expression. Remember, it's when the x is two huge number, positive or negative. Entonces you negligible, ignore, this is completely negligible, this 3, and this 4. Because the infinity means 10 million, 10 billions, 10 trillions. It's infinity, right? So our behavior expression look like that. 1 over 4, x stay the same, 2x cubic. I delete mentally in my mind these 3 and this 4, and x squared. Therefore, you simplification a little bit. This is, no, wait. This is 1 over 4. This is x. This is 8x cubic. And it's x squared. Because 2 to the 3rd power is 8, no? And 8 divided by 4 is 2. So the end behavior expression is 2 x to the 6th power. Let me see, because it's 1 plus 3 is 4 plus 2 is 6. This is the end behavior expression. Okay, super. Without expand, you totally ignore the term can contain number because it's the end behavior. And the degree is 6. And the coefficient is 2, que es positive. That means our graph look like that. Que es when the x approaches to infinity, positive, y approaches to infinity, positive. And when the x approaches to negative infinity, y approaches to positive infinity. In other words, this is right up, left up. Our graph looks like that. When you finish the graph, you expect something like that. Make sense or no? Make sense or no? Clear or confused?
Yes.
Clear, right? So you understand very well end behavior? This is important when you try to do the graph. Get the thing we are doing now. When you try to do the graph of the some polynomial function and behavior. Okay, let me now to explain another thing, is the zeros. How you determine the zero, the solutions of the polynomial. Look. May I erase? Yes or no?
Yeah.
Yes, okay. Now identify zeros and multiplies multiplicities of zero. Entonces, we dedicate a lot of time doing that, but today, for a moment, I am doing using factorization. Suppose this function. This is example to illustrate identify zero and multiplicity. Look, f of x equal x to the cubic power plus x to the second power minus 9x minus 9. This is given like that. Degree 3. Coefficient is 1. Leading coefficient, of course. Okay, the coefficient in front the dominant term is 1. Entonces I know that the end behavior of this look like that, I suppose. Yes or no? However, I need more. I need the zeros. The zero you copy x cubed plus x squared minus 9x minus 9 equal to 0. So it's basically the zero is the x-intercept. Is the point in which the polynomial crosses the x-axis. Okay, entonces yo in this case, no, but in this I apply factorization by grouping. I select this guy, and I select this guy. And the GCF in the first couple is x squared, x plus 1. And the GCF in the second is negative 9, x plus 1. Okay, grouping. Now, x plus 1 again is common factor. Those are factorization, and the second parenthesis we have x squared minus 9, right? And this x squared is this, it's going here, and this negative 9 is going here. I finish, no? No, because I saw another difference of a square is x plus 1, open two parentheses, and the square root of 93 plus or minus equal to 0. Guys, I suppose you remember very well that formula. A squared minus b squared is equal to a plus b times a minus b. Do you remember that or no? Difference of a square.
Yeah, I remember.
Exactly. Okay, as a factorization. When you see factor completed, you apply any technique together. No? You apply grouping, you apply difference of a square, dependent, trinomial, whatever you want. So now you separate one by one. You have three factors. The first factor is x plus 1 equals 0. The second factor, or x plus 3 equals 0. Or the third factor is x minus 3 equals 0. Therefore, one solution is negative 1, another solution is negative 3, and another solution is positive 3. Entonces, with this information, I am ready a little bit to determine, because basically this is 3 point, que es the point, negative 1, comma 0, this is negative 3, comma 0, and this is positive 3, comma 0. Okay, now I am ready to do approximately, you know, the graph of the polynomial. Let me try to do my best. Let me see if I have a rectangular coordinate system. No. No, not here. I suppose que here. Yeah, there you go. I got it. It's a rectangular coordinate system. Look. Okay. Okay. Okay, I have 3 points. Negative 1, comma 0 is here. Negative 3, comma 0 is here. And 3, comma 0 is here. What more information we have? Well, we have the y-intercept. This is a 3x-intercept. This is x-intercept. Would be fantastic to have one y-intercept, because actually we have only one. Only one. Entonces es, how you find that? You evaluate en 0, the function. Entonces 0 cubic plus 0 square minus 9 times 0 minus 9. Es obvio que es negative 9. And the point is the point 0, negative 9. And 0, negative 9, wow, it's here. 7, 8, and 9, approximately. I know that the aim behavior look like that. Entonces, doing approximately roughly sketch of our polynomial function look like that. Look. Aim behavior. Do you see the application on the aim behavior? Look, this and this. Got it?
Yep.
However, hello, we are doing the fantastic way. Are you familiar with the Desmos?
Desmos,
are you familiar?
like, yeah.
Desmos,
Yeah.
do you see before or no? Or never?
The app, yeah.
Yeah, this application.
Yeah.
You see it, right? No, fantastic. We're using every day. Desmos. I want to show you now. I want to show you. Let me try. Desmos. Open Desmos. Okay, I have account in Desmos. Okay, super. Do you see Desmos?
Yes,
Do you see?
yes.
Look, I did this, the first example, I did that. Look, x cubed plus x squared minus 9x minus 9. The point I plot was negative 3, 0, negative 1, 0, 3, 0, and 0, negative 9. Boom. There you go. This is the way that you are doing the test. Okay? Now you show me in the piece of paper the computation, the calculation. However, when you are doing the graph, we are doing using Desmos. And suppose que in the test, on paper, you click here, look, share the graphic, and you export like a picture. Look, you download and send me by email. Okay? Fantastic. This is 21st century, United States of America. Okay? Okay?
Got it.
Yeah, let's do one more example. But first of all, I want to clarify something. I want to clarify multiplicity. What is multiplicity? Because it identifies 0, I did that. But what is the multiplicity? Let me try to explain multiplicity. Okay, look. Suppose
We don't see your whiteboard.
Thank you. Thank you. You appreciate so much. Because I concentrate in the mathematics, entonces I forgot to share the screen, you know. Thank you, thank you, thank you. Now it's okay? It's okay?
Yeah.
Yep.
Suppose, you see the whiteboard, no?
Yep.
Suppose that this is a hypothetical example. Suppose x squared, x minus 2 cubic, and x plus 4 to the 7th power. Okay. By curiosity, unfortunately, I don't know. This polynomial is expressed in factory form. Somebody do the factorization, but I don't care. Suppose that you need to find a behavior expression. Remember, you delete mentally these two and this 4, no? This is not important. You have x squared, x cubic, x7. This is x12. So the degree of this polynomial is 12. When this situation happens, I suppose you have 12 zeros. But it's easy because the 0 is you take one factor 1 by 1. Suppose x squared equals 0. That's the first one. It's obvious that x is 0. But the multiplicity is 2. Because the exponent is 2. I want to explain in detail that part. The second is x minus 2 cubic equals 0. It's obvious that x is 2. Because 2 minus 2 is 0, 0 cubic is 0. But the multiplicity is 3. Because the exponent is cubic. And finally, x plus 4 to the 7th power is equal to 0. X is equal to negative 4. And multiplicity is 7. And it's no coincidence that when you adding 7 plus 3 is 10 plus 2 is 12. It's exactly the degree. And actually, the 0 of the polynomial is, you can write like that, for example, 0,020, because the multiplicity is 2. We have 3, 2, 1, 2, 3, and 7, negative 4. 1, 2, 3, 4, 5, 6, and 7. Well, this is too long. The best way is indicate the multiplicity. So 0, multiplicity 2 times, 2, multiplicity 3 times, and so on. It's important to know that when the multiplicity is even like that, the graph touch the suppose that this is my x-axis. Look, this is my x-axis. Okay, entonces en 0 touch. Y en 2 and negative 4, 1, 2, 3, and 4, cross it. Okay, cross it. Now, when the multiplicity is even, the graph touch x-axis. When the multiplicity is odd, cross the x-axis. But I know something extra. I know that the end behavior of this case 12 look aim behavior, and the coefficient is positive, the aim behavior look like that. Makes sense or not? Right? Now, so you want to do the graph of this approximately, you know, no accuracy. Approximately is this is cross, this is touch, and this is cross. So the important information I try to explain is when the multiplicity of the zero is even number, multiplicity 2, the graph touch. But there are two different ways to touch. Touch like that or touch like that. You don't know. It's not giving the information for this. It's giving with the aim behavior. Okay, I know that the aim behavior look like that, like a U. And this is cross. Do you see it cross the axis? Cross the axis, and this no cross, touch. So touch down here, not up. Make sense or no? No? Guys, are you there?
Yeah, makes sense.
Okay. Okay.
Yes.
Yeah.
Yes.
Yeah.
With this information, we improve a little bit to understand the graph of the polynomial, no? Suppose 1 second example. 1 second example. Example 2 is f of x is equal to x to the 4th power minus 4x to the 2nd power. And that's it. This is our polynomial. Entonces, I want to summarize everything. Find the aim behavior, okay? Identify the zero of this polynomial and determine the multiplicity and try to do approximately, you know, the graph of this polynomial, okay? Entonces, aim behavior es obvio. Aim behavior es obvio que es x to the 4th power. So you take always the polynomial, the monomial, you have the higher degree. And this is the degree of the our polynomial. Entonces now, look at this degree, even and coefficient is positive, look like that. Okay, it's right up, left up. Now identify the zero. Identify the zero is x to the 4th power minus 4 x to the 2nd power equal to 0. So to find, guys, the x in a set que is equivalent to, say, zeros of the polynomial, you take the function and you enforce it to be equal to 0. Okay, you take the function and you enforce it to be equal to 0. And now you convert this like an equation and you solve this equation. Okay, in this case, the great common factor is x squared. We have x squared minus 4. Wow, so you now determine you continue factorization different of a square. This is stated like that, but this no, I break it down like x to 2 plus or minus equal to 0. So now we are ready to determine the 0. The 0 is x squared equal to 0. That means x is 0 and multiplicity 2, because this exponent is 2. However, we have two more factors. Okay, it's negative 2, multiplicity 1, because the exponent is 1, invisible. No, we have no exponent here and no here. And x minus 2 equals 0. X is 2 positive, multiplicity 1. And remember, multiplicity even, touch. Multiplicity odd, cross. And we have some idea how it look like the graph. Okay, by curiosity, we determine why not the y-intercept. Y-intercept formula is you plugging in 0 in the origin. This is the formula, guy, to find the x-intercept. This one. And this is the formula to find the y-intercept. Es obvio que es 0 to the 4th power minus 4 times 0 squared. Es 0, es 0. That means que the point 0, 0 es both. It's y-intercept and x-intercept. Okay, entonces we are ready. We are ready to see the, or to do approximately, you know, the graph of the polynomial function. Here, over there. Okay, there you go. Okay. Here. Okay, let me start for the 0. 0 and 0. And 0 and negative 2. And 0 and positive 2. And the y-axis is 0,0, que is by coincidence x and y. And the aim behavior, I don't remember. Oh, it's like that. Look. It's like that. Entonces, it's our graph. I suppose doing, you know, a rough sketch, no accuracy. It's like that. Aim behavior. Okay. It's important to say that the graph of the polynomial function never have a corner like that. So suppose you are doing like that. This is wrong. It's a smooth curve. It's smooth. Let me try to do my best. This is not good. So passing through the point 2, 0, and negative 2. But I know that the aim behavior start here. Okay. Now it's move like that. And the rest is, you know, it's obvious. I'm doing not well. This is completely symmetric because this is even functions. So it's you replace and the original function. So you replace and the original function. Look at that. So you replace and the original function. X for negative x. Okay, this is the original. And you replace negative x to the 4th power minus 4 times negative x to the 2nd power. It's obvious that when the exponent is even number, I don't care the sign negative. It stays the same. That is x to the 4th power minus 4 x to the 2nd power. This is identical to the original. Therefore, that means that our graph is completely symmetric with respect to the y-axis. And that part is identical. Flip it. It's an image of this. Any question? Any question? Any question?
Yeah.
No.
Super clear? Super clear?
Yes.
Okay. So the only thing that we study to identify the 0 of the polynomial is by factorization. What's the problem? Que factorization is very, very weak. And the majority of the example we cannot do by factorization. So I propose you another fantastic way to do the factorization without factorization. Okay, so I want to recall something about algebra. Long division, polynomial. Long division. Long division. Let's see example. A refresh your memory about long division. Long division is you divide one polynomial divided by another polynomial. It doesn't matter the degree. Let me start for the easy problem, not complicated. It's 2x squared plus 3x minus 14 divided by x minus 2. Entonces, what is the format for the long division? The format for the long division is look like that. You copy the numerator, okay, que es the dividend inside the box. And you copy the divisor outside the box. And you start division. And division is you try to find one expression here, copy in the quotient part, que multiply by x give me 2x squared. It's obvious que es 2x. Because when you multiply 2x times x is 2x squared, identical to this. And when you multiply 2x times negative 2 is minus 4x. Do you follow me? Do you follow me?
Yep.
Now, by subtracting, you change the sign. You say, well, professor, but what is the reason guys subtracting? Well, because when you are doing in arithmetic, the division, you put 2 times 2 is 4, subtracting is 1, no? Entonces, the division is an algorithm que es multiplication, subtraction, multiplication, subtraction, multiplication, subtraction. It's a typical division algorithm. That is the reason that when I multiply, I change the sign. Intentionally, this is canceled out, and this is 7. Bring down why you know okay, you need to continue. You need to continue because the degree of this expression is 1. And the degree of the divisor is also 1. That indicates also okay, you need to continue division. When you stop division, when the degree of the hypothetical remainder is less than 1, the degree of the divisor. See, the degree of the divisor is 1, you stop when the degree of the remainder is 0. Or not necessarily 0 remainder, is 0 degree. In this case is 7, no? Well, bring down negative 14, sorry. And you put here 7. 7 times x is 7x. And 7 times 2 is negative 14, but by subtracting, I change the sign, is 0. And the answer of this division is 2x plus 7. Do you remember now? Do you remember long division? Yeah. However, I have the shortcut to do fast and quickly. Is synthetic division. And this is the way we are using every day. Pay attention, it's important. Synthetic division is the fantastic way to do exactly the same. What is the reason? Okay, there are two, long division and synthetic division. Well, okay. Synthetic division is only possible when the degree of the divisor is 1. So when the degree of the divisor is 1, is the only possibility you have to create synthetic division. Get a shortcut of this. It's similar, but it's shortcut. Therefore, long division is more general. Long division is applied always, anytime, when the degree of the denominator is 2, 3, 4. But in this case, when they 1, we can do using long division. So what is the format for the synthetic division? Well, okay, you copy the same symbol, but you copy now the coefficients in the numerator, que es 2, 3, and 14. And no specification on the x, because default you suppose that this is x to the 0, x to the 1, and this is x to the 2nd. So you suppose this. And you copy outside the divisor, pero opposite sign, 2. No negative 2, sino positive 2. What is the reason gets opposite sign? Because you change the sign one time, you don't need to change any time, subtraction. No, only one time. You change the sign. Si es negative, si the factor is x minus 2, you put in the synthetic division positive 2. Si es plus 2, you put negative 2. Now, what is the algorithm? The algorithm that you bring down to bring down, not do anything, just bring down. And multiplication this and this. 2 times 2 is 4. We combine this, 3 plus 4 is 7. You multiplication this and this. Sorry, this is negative. I make a mistake, it's negative. F14, 7 times 2 is 14, and the remainder is 0. Wow, exactly. This number is exactly that number. Look, this number, remainder, is exactly the same. And the new polynomial is the answer, is 2 and 7, but this is x to the 0, and this is x to the 1. And the answer is exactly the same of this. Do you see that or no? Do you see that or no?
Yeah.
You see, right? It's beautiful. It's fantastic. Let me explain one more complicated example. A little bit. And that's it for today. Okay. One more complicated. May I erase the board or no?
Yes, sir.
Yes.
Yes.
Okay, super. Suppose I need to do this guy. Division, negative 10 x squared plus 2 x cubic minus 5 divided by, using that symbol, x minus 4. Divided by. Okay, let's do it. The professor explained me that I opened this box similar to the long division. I put the coefficients, but be careful, I put intentional to confuse you. You need to organize this polynomial in descending order of the degree. The higher degree is 3. Therefore, this is 2. Que corresponde x cubic. This is totally optional to write this. Now minus 10. This is x squared. And x to the 1 power is missing. Therefore, you put 0. It's important to organize, and when the one guy is missing, you put 0. And x to the 0 is negative 5. Do you understand very well this? Now you put 4. You put 4 here. Positive 4, remember opposite sign. Bring down to multiplication, 8. Negative 2. So negative 10 plus 8. And negative 2. Negative 2 times 4 is negative 8. Negative 8 and 0 is negative 8. And negative 8 and 4 is negative 32. And this is negative 37. And that's it. I finished. This is a hypothetical remainder. So what's the answer? Well, the answer is, this is x to the 0. This is x to the 1. This is x to the second. The answer of this division is 2x to the second minus 2x minus 8 plus minus, because it's negative here, 37 divided by x minus 4. Because we have remainder. See, the remainder is 0, that part is missing. Okay, but in this case, no. It's similar to the elementary, and I got the example. 5 divided by 2 is 2. 2 times 2 is 4. Subtract the remainder 1, to say 1, 2, 1.5. What comes from this one? It's this one. In our example, it was negative 37. So basically, the formula is quotient. Who is quotient? This is quotient. Plus remainder. Who is remainder in our example? Negative 37 divided by divisor. Well, okay. See, the remainder is 0. This is just a quotient, exactly like in the first example. Make sense, guy?
Yes.
Okay, one more example, and that's it. You need to be strong next time for synthetic division. This is the key to understand the polynomial, right? Let's do one more example. Suppose negative 2x plus 4x cubic plus 18 plus x to the 4 power divided by x plus 2. Okay. I put the box. I put the numerator, que is the divisor. Divisor, no dividend. I organize. What is the leading coefficient? Is 1, no? Que is x to the 4 power. The next is x to the 3rd power, get 4. The next is x to the 2nd power, get missing. They are not exist. X to the 1 power is negative 2. And x to the 0 power gets 18. And you divide by a negative 2 here. Get the opposite side to the factor that we need to divide. That part is completely optional. That part is not necessary. I put it here to illustrate you the organization, no? But no, this is not important. So now bring down 1, multiplication and negative 2. Combine this as positive 2, multiplication and negative 4. And negative 4, multiplication is positive 8. Now is 6, no? 6, and 6 times negative 2 is negative 12. And now remainder is 6. Okay, perfect. Now what's my final answer? My final answer is x to the 0. You start always 0 here. X to the 1, x to the second, x to the good. Make it sense. By the way, 0, 1, 2, 0, 1, 2. No, wait. Yeah. Okay. What is the degree of dividend? The degree of dividend is 4. What is the degree of divisor? Is 1. And that is a reason that we can apply synthetic division, no? Otherwise, no. Entonces, the degree of the quotient is decreasing. 4 minus 1 is degree 3. So the answer is x cubed plus 2x squared minus 4x plus 6 plus 6 divided by x plus 2. Boom. Final answer. Super clear or super confusing?
Very clear. Very clear.
Super clear, right?
It makes sense.
Okay. Okay, so we stop. It's enough for today. We continue to use it. Remember, I encourage you try to sign in Alex. Okay? It's easy. You have no money now. 2 weeks free. Okay, I want to see in my roster when you sign in. Okay? I check in this weekend. Okay, guys. Pleasure.
I have one question before you
Go
leave.
ahead.
Go ahead. We don't need to buy the math textbook, right? Just Alex?
No, only Alex. Get cheaper. It's $60 something.
All right. Awesome. Thank you.
Book is super expensive. $200. No. Only. Let me stop recording because